It's the Daily Space Weather Show, and thanks for tuning in. That is a 48-hour video of the closest star, and there'll be a lot of people viewing the closest star. And so, yeah, well, it's the Sunday edition, so we hope you're wearing your Sunday best. If you're not, then if you're not watching the live premiere, then press pause, put on your Sunday best, and then come join us. Definitely don't wear your eclipse glasses. Those will not work well. However, the Smash News Network, least busted name in news, there it is, will work very nicely. Let's talk about wavelengths for a brief moment. Wavelengths. So if you view the sun from the ground, it's not really that exciting looking, right? And that's partially because of the Earth's atmosphere filtering out portions of the spectrum. If you view it from space, you can see awesome things like the 171 angstroms wavelength. So here that is. And let me just sort of explain what the 171 angstroms is, because we get lots of comments where people say that's CGI. And ultimately it is CGI. Well, all digital imagery is CGI. And keep in mind, folks, with the human eye, you're only able to see this small portion of the electromagnetic spectrum. These are all photons. These are photons. These are photons. And we're talking different frequencies, different wavelengths, whatever you want, however you want to call it. And the SDO is up here in the extreme ultraviolet portion of the electromagnetic spectrum, not visible to the naked eye, and even if it were, it would not be visible from the ground because the atmosphere filters that out. So it is definitely CGI. But then again, so is all of your digital photography. That's why you can take imagery of a flashing remote control light, which is infrared. You can't see that either with the naked eye, but you can see it with artificial instruments. So the SDO is one of those artificial instruments. And here's what happens if you combine it with, now we still got the SDO 171 there, but we now added the GOES SUVI 304 angstroms. So you're looking at ionized helium and iron. Again, not visible from the ground, and not visible to the naked eye, even if it got to the ground, which it doesn't. It's filtered out by I believe by the D layer of the ionosphere. Those wavelengths are gone. X-rays make it all the way down to the mesosphere. Or maybe the upper stratosphere. I think the upper stratosphere, actually. But yeah, so those are 24-hour videos for you. And we'll be seeing lots of solar features in the coming days. So here's a forecast for you. You'll be seeing lots of solar features, and many of them will be around the edge of the solar disk. So many of the prominences that we'll show you in this video will indeed be featured in other imagery from ground-based systems. So this is a prime example of how many of these features, they still are visible, just not in the wavelengths that we're currently viewing them. So these large prominences, they do appear during a total solar eclipse. So all of these sorts of features, many of these, new ones will rise in the east, and some will set in the west, but some more will rise in the west as well, meaning they'll become prominences. Solar filaments are the same feature as plasma gets suspended by magnetic fields, allowing it to rise tens of thousands, hundreds of thousands of kilometers above the chromosphere, with the transitional zone just above the photosphere and just below the solar corona. So many of these features, there's a new sunspot rising back there as well. That will all help to create features that people will be photographing from the ground level. And of course, 171 angstroms is a fantastic wavelength. But let's digress for a moment here and head back to planet Earth, as we've got some interesting activity happening in Iceland once again. Now, one of the walls of this cinder cone has now collapsed. So we're getting an active lava flow now, so that's pretty sweet. For all of you lava enthusiasts, not so sweet for the town of Grindavik, though, as some of those lava flows may be less than optimal for things like the architecture. So, but a quite active flow now, as one of the walls of that have collapsed, allowing the only live cinder cone to start to empty out. So new real estate forming there at Iceland. There it is at 2040 local time. So the eruption continues there, but it is continuing to slowly diminish. Luatolo also erupting. Popocatépetl, Santiaguito, Fuego, Sangay, and Sabancaya. Earthquake activity still seems kind of high. Let's hope none of these quakes are foreshocks, folks, because foreshocks are super spooky. I mean, that they make any earthquake super spooky. It's one of the only things that give us some idea of a larger event soon to happen. So, I mean, I think we have like a 10%, is it a 10% chance of an earthquake being a foreshock? One of our viewers chimed in about that. Leave us a comment if you know what the probability of any earthquake being a foreshock. It's like 1 out of 10 or something like that, which is basically a better statistical analysis than any YouTube channel that claims it forecasts earthquakes. Probably less than 10% accurate. Anyway, these are the quakes of the past 24 of a 5 and greater magnitude. New Caledonia had a 5.0. South Sandwich Islands had a 5.0. Look at the quakes around the Pacific. The northern and indeed eastern Pacific there. Papua New Guinea had a 5.2. Chile had a 5.1. That earthquake was made in Chile, not in the United States of America. Okay. South of Fiji Islands, we had a 5.0. That one was at great depth, 353 kilometers. And Bandar Lampung, Indonesia, had a 5.2, and also El Salvador had a 5.0. Headed back to space weather. That's where it's at. And there's the 171 angstroms wavelength, another 24-hour video from SDO, 30 frames per second. And that is the house favorite wavelength. Again, it's fantastic at showing those prominentiary features, which will be heavily viewed during tomorrow's festivities. So we won't spend too much time talking about the eclipse as, well, it's not really space weather. Is it really space weather? I don't think it's really space weather. It's certainly an astronomy event, an astronomical event. It does give us the ability to see aspects of the corona that we wouldn't be able to otherwise see. So that's always fantastic. But anyway, back to some stats here. The 10.7 centimeter radio flux is, go away, now at 123 solar flux units. 123 is the radio flux number. And if you're wondering what a solar flux unit is, well, it's 10,000 Jansky of radio flux density. I mean, who doesn't measure their radio flux density in Jansky? Only idiots. Anyway, space weather enthusiast dashboard's next, and we ain't got no space weather on the way. Things are pretty chill between Earth and Sun space weather. We cover it from the photosphere all the way down to planet Earth. So there is Noah's Enlil spiral, and as you can see, not very exciting times to come for the next few days. And guess what? ESA does have a small thing happening there. Looks like they do have an Earth-directed CME. So it looks like some plasma there, according to the ESA. But it's very minor. That's a coronal hole high-speed stream, it looks like. So I think that's what the forecast is there. They're expecting a coronal hole high-speed stream's high-speed portion to show up around on the 12th. The density wave sometime on the 11th. Or maybe late on the 10th. Anyway, here's Earth's magnetic moment from space, and things are calm. We've got most pressure in the magneto-tail side, so you're going to see a bit of an equilibration happening there. And it's causing a little bit of perturbation in the ionosphere, actually. So we're seeing a little bit of action just as a result of plasma trying to reach equilibrium. And we'll show the ionosphere. It's nothing particularly exciting. It's only a minor effect that you probably wouldn't notice if you had no idea how the variables relate to each other. So here's our ground magnetic perturbations map. And now keep in mind, folks, these are models, but they're based on lots and lots of data. So, of course, any model's based on lots and lots of data. We've used this to forecast where we'd be able to see the aurora, and it's been quite good. So there's a little bit of activity going on there. But the KP is only at 1.33. So basically the magnetosphere is sort of snapping back into its... Well, you're going to see a homogeneous magnetosphere in the next 6 hours, assuming nothing shows up in terms of like solar wind changes. At the moment, quite slow and quite nominal solar wind. So on the Discover, that was the ace we just showed there. That was about 4 protons per cubic centimeter at 381 kilometers a second. The Discover is 4.5 protons per cubic centimeter at 400 kilometers per second. That is a very average solar wind. Not remarkable at all. Here's our GOES magnetometer data, and also not remarkable. Here is our magnetic sector data, the heliosphere in terms of magnetism. Earth is moving toward the edge of a North Pole-oriented magnetic sector. That should arrive in about 36 hours. Here's our line of sight field plot. And, yeah, that's a lot of data. That's a lot of data. Here's our coronal hole line of sight plot. We do have some South Pole-oriented coronal holes here rotating in. And let's take a look at those from the SDO. So there's our 211 angstroms wavelength. And before we get to sunspots, let's take a look at sunspot number and things. There's our sunspot number according to Rob, the Royal Observatory of Belgium. Sunspot number here at, what do we have, 85? 85 sunspots. And we can expect sunspot number to rise tomorrow. We'll tell you why here in just a moment. It's because we have new sunspots. So assuming that, none of the ones that are already named degrade, we can expect a couple new sunspots here. I believe we'll have 3634 and 3635 will get names in the next 24 hours. So there's that. And here are sunspots from the spectacular, the stupendous, the SDO. So they're all pretty stable there. The one up in the northeast has grown. So that one, I don't believe that was there. That one did indeed form while in view. And besides that, things pretty stable there, pretty stable. Oh, no, a little bit of degradation there in the west. So we may lose some sunspots and gain some sunspots. We'll have a modest uptick in sunspot number in the next 24 hours. And let's move on to... But wait a minute. There we go. So a little bit of degradation there in the west. A little bit of growth in the east. And I think a couple new sunspots to get named over there in the east. Anyway, before we move on to solar flares and energetic particles, before that, nothing, because here are solar energetic particles and solar flares. Proton flux is flatlined. The X-ray flux barely saw a C-class intensification there. So very low levels of solar activity here. About, let's see, what are we, like 6 months out? About 6 months out from the likely time for solar sunspot maximum. And before we get to things like solar system forecasts, let's go back. Let's go back to space to put the 131 angstroms 24-hour video right in your face. And there's our zoom in. I do not know why the screen is clipped. Actually, I do know why. It has to do with zoom features. So I apologize for the clipped screen. That should be full screen. I don't think I can... Oh, I guess I can blow it up. Okay. But then if I blow it up, it's going to mess up other views. All right, that's as big as it gets. So that's 30 frames per second. Ionized iron, 131 angstroms. Also a portion of the extreme ultraviolet. Part of the electromagnetic spectrum. Most likely place to see large solar flares would be in the east. And before we get to CMEs and coronal mass ejections, a solar system forecast for you. Here is the next week. And by the way, if you get up before dawn tomorrow morning, you'll see a great view of Venus and the moon very close to each other. So, here's your 1 week forecast for the solar system. New moon coming. That is where things will be on April 14th. Okay. And this is what's going on overhead. And let me just advance this. So there it is now. You can see the moon and Venus very, very close to each other in the sky, but not really very visible. But if we advance this into tomorrow morning, you see Saturn and Mars rising, and then Venus and the moon right ahead of the sun there. So it's a fantastic morning to watch the sunrise tomorrow, as you get a great view of Venus waiting for that to happen, and a tiny, tiny sliver, maybe not even a visible portion of the moon, showing up early in the day as it overtakes the sun, or I guess the sun will overtake the moon. Here's an eclipse from Wyoming. That is our astronomy photo of the day from apod.nasa.gov. And this is basically what all of you will see who are in the path of totality, something like that. Make sure you bring your solar shades that you bought from our Amazon shop, linked below this video. Of course, if you want them now, it's a little bit too late. But hey, maybe for next time. And let's move on to CMEs. So there's what's going on for CMEs, and this latest CME here, I'm calling it the Dracula coronal mass ejection, because I think it looks like Dracula. So I'll show you why here in a minute. That's 75 frames from today from George Mason University. And look at this. This looks like Dracula. It's 100%. I mean, dude, seriously. Look at this. Here's his cape. Here's his mean eyebrows and his widow's peak. And then, you know, his fangs would be right down here somewhere. It's the Dracula CME, folks. I mean, on this side, it's even more obvious. Look at that. There's his eyes. There's his widow's peak. There's his cape. It's the Dracula CME. Case closed. So there you'll see it popping up. And, I don't know. If you don't think it looks like Dracula, too bad. Too damn bad. If you're mad that it looks like Dracula, we're terribly sorry. There it is. Or maybe it's a falcon. Or a phoenix, perhaps. Rising from the ashes of other space weather channels. We'll also show Stereo A and its difference imagery, and once again, from Stereo A's perspective, it looked like Dracula. Let's move on to our custom CMEs. Our custom imagery here. Oh, there we go. And let's blow that up. That's a little better. That's not half bad. Is it earthly directed? Well, absolutely not. It's somewhat on the far side. And we'll zoom in a little bit closer here. There we've put together that's the SDO 193 angstroms along with the GOES 16 SUVI 304 angstroms. There are those together once again. Not too bad. Great at showing filaments. And of course we moved on to that segment, haven't we? Yes, we have. Yes, we have. Yes, we have. So filaments, there they are from Cerdo to Lolo, and we've got a lot of massive ones pointed at the Earth. Now, many of these features down here may set by tomorrow, or they may eject, but we've got some new rising features here in both the eastern limb and on the western limb. So, let's see, in about 24 hours, this one might be a prominence, so this will be a place to look. That'll be a feature you may be seeing on tomorrow's eclipse imagery. So, lots of filaments there. I think perhaps some of those ought to get named. What do you think? And if you'd like to name them, join us over on x.com/Smashomash, otherwise known as Twitter, what sane people call Twitter. You know, a brand, an actual brand. Now, today we're showing the GOES 16 SUVI for our bonus feature segment, or for the intro to our bonus feature segment, because this is what a lot of the imagery will look like. So if you like take a round circle and put it over that and just look at the outside of it, many of the imagery will look a bit like that. And you know, we certainly hope that you've got a ground-based telescope. If you've got a solar telescope and you want to share imagery on the channel, hit us up. The best place is to just post about it on X or on Instagram or YouTube, and then just hit us up and let us know in the comments or something like that, and we will hook you up. Wink, wink. We will hook you up with coverage on the channel. Yes. So, yeah, that's the past 4 hours from the GOES 16 SUVI, 171 angstroms. And like those sorts of features there, they'll be quite commonly seen, especially the eastern limb. So you'll know what part of the sun you're seeing. Of course, it might be at a weird orientation from what part of the planet that you are on and what time of day you see it and things, and I'm not going to get into all that. I'm just going to get into bonus features to get to the meteorology segment, to get this video onto your screens. And by the way, thanks to everybody who tuned into the live premiere events. We attend those as well. So, because folks, I'm not only Smashomash, but I'm also a client. So we ain't got any charging hazards. The GOES electron flux here, just moving into warning levels there for the GOES 18's radiographic measurements. There's the past 1 year. And yeah, so some perturbations happen in the ionosphere. And again, it has to do with the equalization of the plasma in the magnetotail. That is our electron flux forecast by NOAA. Expecting it to rise a little bit here. I don't know. It's sure. And next, the ionosphere itself. So here is the ionosphere. And again, it's a little bit puffed up in some spots right now. And that shows up as low-frequency anomalies on this imagery. And if you're not familiar with looking at that imagery, no worries. We show the anomaly in megahertz from a 30-day median, so you don't have to have any idea what you're looking at. That is the anomaly from the 30-day median in megahertz. Blue is high-frequency anomaly, and red is low-frequency anomaly. There it is. And yeah, there's definitely a weak spot there, crossing the Atlantic Ocean, connecting the South Atlantic anomaly and the African anomaly. So if you look at, so right here's the South Atlantic anomaly. It is over the South American continent. There's also another one right here around coastal equatorial Eastern Africa. Right about here, there's another one. And that is the weakest point of the magnetosphere. It's kind of like this. So you're always going to have a huge gradient there. And that is an area where the magnetosphere dips down, and you know, that isn't like an imperfection. You know, people think of the magnetosphere as a perfect thing, and it's not perfect at all. It's all lumpy, and that's a divot, essentially. That is a divot in the ionosphere. And of course, you'll see daytime, day to night transition and night to day transition anomalies happen there. That is what occurs. It has to do with the way the electrons want to travel. And so, yeah, but there it is. There's the Global Ionosphere Nowcast, or WHAM, the Whole Atmosphere Model. Last but not least, before we get to meteorology, there are our latest images. And okay, we're in small screen. That's good. So that's a new sunspot. That'll get a name. I thought there was another one down south of that. Okay, maybe not. So, but anyway, sunspot number to be somewhat steady for the next 24 hours. And let's move on to meteorology. By the way, don't forget to press the like button if you enjoy the content. Press like, lest thy soul be cast into an ever-deepening and darkening abyss of spooky, spooky cold and warm water mixing in the northern Atlantic. Ooh, watch out for that spooky, spooky water, folks. But seriously, in all seriousness, watching this part of the planet right here is sort of like watching the pulse of the northern hemisphere's climate. I mean, anybody who knows anything about this should, well, I don't care if you agree or not. It's just a fact. That is, you know, according to the geologic record, that is the area where stuff happens when major climactic changes occur. Because keep in mind, folks, the Earth does have a positive feedback mechanism. It's called the albedo effect. In other words, there are mechanisms that make the planet want to kind of make itself not too hot. However, the mechanisms that make the planet way too cold for civilization to exist, they're a positive feedback mechanism. So there are negative feedback mechanisms for warming, but for colding, there is a positive feedback mechanism. It's called albedo. When you get enough snow in the northern hemisphere, that's bad. In other words, if snow extent gets extremely, extremely high, that's bad. It reflects too much light back into space, and that's not good. Owning rear view shades is good, though. Yeah, they're Raisin Bran. No, you can't get a set. They cost $1 trillion a pair. You might be able to get a set from what's that company that sells the extremely rare stuff? Sotheby's. You might be able to get one from a set from Sotheby's, but besides that, you're screwed. You can't have the glasses, folks. They're like Raisin Bran from like 1986 or something, and they are rear view shades. So don't try to sneak up. Not gonna work out for you. You may be kicked in the head. Just kidding, folks. Violence is always wrong, except when it's necessary. So anyway, there's the North Atlantic. That is a sea surface temperature anomaly. Now, sea surface temperature, raw temperature. There's the anomaly, and that's currents. Currents are the animation, and sea surface temperature. There are the world's sea surface temperatures. There's the the Southern Ocean. There's the Indian Ocean. There is the mighty Pacific. And there is the Arctic. It's not melted yet. No, it's spring, but it's not melted yet. All right. The planet's surface winds shown here, jet streams shown here. Let's get serious about meteorology. Central world's jet streams, central world's surface winds, western world's surface winds, and jet streams. As that low finally screws off, everybody join me in giving that low the bird. Yes, screw you, low. That low that's now moving up toward Newfoundland, that low can screw off. It caused it to rain like all week, and people didn't like that, including me. Anyway, here's our satellite imagery, and we'll speed things up a little bit as this video is getting lengthy. So there's our fantastic satellite imagery. And by the way, it looks like we're going to have clear skies over eastern Pennsylvania tomorrow for the eclipse. So delighted for that. We do have multiple pairs of eclipse glasses. No, you're not invited to our eclipse party. Next, precipitation type. And yeah, you've got a mixed bag. A mixed bag. And part of that mixed bag, this part right here. Oh, now wait, there we go. Part of that mixed bag right here is full of hallucinogenic drugs. Just saying, not knocking it. Just saying. So some snow and some rain falling in the U.S. nextweather.gov, and that's... I've vanished into... I've vanished into some thickness of air. Holy cripes. Son of a bittern! Anyway, there's the key. There's the map. I'll scroll back down and show you the key again. So you can match the Can you match the colors? This is Candyland level, folks. Candyland level. You don't have to be able to count or recognize letters or numbers. You can just match colors. Oh, you'd still have to read. Anyway, there is some flooding on the map and some snowing on the map, so we'll show those things. There's our snowfall accumulation in inches, 72-hour GFS model. 72 hours is 3 days, by the way, if you can't do basic arithmetic. Here is our 72-hour GFS accumulated precipitation forecast, also in inches, just like the snowfall. And check it out, Arkansas is going to get kaplastered with 5 inches of rain. 5 inches of rain. Also, Oklahoma is going to be kayaking down Main Street. Look at the amount of rain. It's berserk. Also, portions of Texas and Tennessee. Well, there's the map. Just look at the map. And here's another one. There is our pressure and precipitation forecast. Snow will continue in some places. Massive rains will come to others as a low forms over eastern Texas. Dag. Last but not least, temperature anomaly forecast in degrees Celsius. The same model, GFS 72 hour. Couple more things to cover. Those forecasts, by the way, come from tropicaltidbits.com. Go say hi to Levi Cohen. Tell him Smasho sent you. He'll have no idea who the hell I am. But feel free to follow him on Twitter. We're delighted to see that the software is back up to functioning and that the hardware problems are now gone. Here's lightning for the past 10 hours. And it's been pretty chill as far as lightning, except in the center part of the country, I think. That's yesterday's. Sup with that. Sup with that, dudes. That is some ancient data. Let's ignore that and move to a real-time lightning map courtesy of lightningmaps.org. So, if you'd connect, that would be great. Don't neglect to connect. There we go. That's better. And we do have a little bit of lightning there over the Midwest. Some lightning south of Chicago, as well as north of Des Moines. Des Moines. Now, I know how to pronounce it, folks. I'm just doing it to get a rise out of noobs on the internet. All right, so there is the full map. Here is our U.S. Doppler radar. Let's zoom out briefly to show our Alaskan and Hawaiian viewers their Doppler. We've got this perfect Fibonacci spiral that's formed here as this low makes its way up toward Minnesota and things. That's what it looks like, at least. Here is our, there we go, moving up toward South Dakota, actually, right now. Right on the Nebraska-South Dakota border. That's our visible satellite. And here is our water vapor map. A great view of that. It is constrained by dry mass of air to its south, which is also providing like a barrier. Since you've got that high pressure there over northern Texas, that is sort of blockading this air and constraining it, corralling it, if you will, and sending all that moisture toward Tennessee. Here's your recap to close this thing out. Doppler radar, visible satellite, water vapor, and me signing off. Thanks for tuning in, and may that solar wind be at your back.